A dry 1.40 grams human tooth was dissolved in a small quantity of hot concentrated triazonitrate acid. A drop of methyl orange indicator was added, followed by drops of 6 molar sodium hydroxide until the indicator turned orange to neutralize the solution. The solution was then made up to 250 cm cube in a volumetric flask. 10 cm cube of this solution was pipetted into a conical flask, and 1 cm cube of a concentrated ammonium chloride pH 10 buffer was added. The solution was titrated with 0.02 mole per dm cube EDTA using Erythrum black tea indicator. The indicator turned blue after 22.5 cm cube of EDTA was added. Calculate the average percentage by mass of calcium throughout the tooth. Now, this is a complexometric titration because it involves the use of a complexating agent, EDTA, that is ethylene diamine tetraacetic acid. So, a dried human tooth, this is the human tooth here. This is the mass of the human tooth. And what's the major content of the human tooth? Calcium makes up the major content of the human tooth and the bones. So, that's why we are asked to calculate the percentage by mass of calcium in the tooth, right? But we can only achieve that by first of all extracting the calcium in the tooth, and to do that we use hot concentrated triazonitrate 5 acid, right? And the hot concentrated triazonitrate 5 acid added to the human tooth dissolved it, but because of the very high concentration of the acid, the solution will still be what? Acidic. That's why a 6 molar sodium hydroxide solution was also added to neutralize the solution, to ensure that the solution of the human tooth is neutral, right? And then this solution was then made up to 250 cm cube in a volumetric flask, which means that 1.40 grams of the human tooth was present in 250 cm cube of the volumetric flask. Fine. Now 10 cm cube of this solution was pipetted into a conical flask, and 1 cm cube of a concentrated ammonium chloride pH 10 buffer was added. This buffer was just added to maintain the pH of the solution, to ensure that the solution does not change, because for a reaction between calcium and EDTA, it works well at pH of 10. So the solution was then titrated against 0.02 mole per dm cube EDTA. Means that the solution of the EDTA that was used to carry out the titration was a standard solution, right? Using this indicator, Erythrum black tea. Now, the indicator turned blue after 22.5 cm cube of EDTA was added, which shows that the reaction came to an end, right? So the EDTA, being a standard solution, was used to determine the concentration of calcium in the human tooth, or the amount of calcium in the human tooth, right? And that's what we are asked to do, to calculate the average percentage by mass of the calcium. So the first thing we'll do is to first of all write out the equations of reactions. First of all, the calcium would be converted to calcium ions by the concentrated triazonitrate 5 acid, as shown here in the equation on the screen. Remember, in this case, triazonitrate 5 acid is not just acting as an acid, it is also acting as as an oxidizing agent, because it's concentrated. It's not just concentrated, but also hot. So the hot concentrated triazonitrate 5 acid acting as an oxidizing agent. It oxidizes the calcium, right, to calcium ions, to calcium 2+, right? Fine. And it is itself reduced to nitrogen 4 oxide. The hydrogen that was formed, right, from the reaction between a metal and the acid is oxidized to water. Fine. It's not the calcium 2 ion that reacts with the EDTA, the ethylene diamine tetraacetic acid, or ethylene diamine tetraacetate, as the case may be, with the EDTA to form a complex calcium EDTA 2+. Now, like I said earlier, that this EDTA is a chelating what? It's called a chelating agent, or a complexating what? Agent. Which is why the titration is called a complexometric what? Titration, because it involves the use of a complexating what? Agent. Fine. So it forms a complex with the calcium what? Ion, and reacts only with the calcium ion. With that, it's easy to determine the concentration or the amount of the calcium ion present in the what? Human tooth. So from this, let's now extract the parameters given to us. We don't even need to extract it because we already know. From the equation of reaction there, you can get the mole ratio. The mole ratio of calcium ion to EDTA that reacted is 1:1. So this is going to serve as a guide. 1:1. Now, from the information provided, what can we do? Is it possible to get the number of moles of calcium? We don't know. So there's no way we can do that, because we don't have any information on that. We don't know the concentration of the calcium ion. We don't know the concentration in grams per dm of the calcium ion. So, but we can get the number of moles of the EDTA, right? From the concentration of EDTA and the volume of what? EDTA that was what? Used. So let's see. Concentration of EDTA solution used is 0.02 mole per dm cube. Volume of EDTA used is 22.5 cm cube, which is equivalent to 0.0225 dm cube. That's by dividing by what? 1000, right? Great, that's it. So from here, you can then calculate the number of moles of EDTA that was used. So the number of moles of EDTA used in the titration, that's N of EDTA, will be equal to concentration of EDTA in moles per dm cube times volume of EDTA in dm cube. And if we substitute the values here, we will get, that will be 0.02 moles per dm cube times 0.0225 dm cube, and this will give us 0.00045 mole, right, of EDTA, or 5 mole of EDTA. Good. So now coming back to our mole ratio. Our mole ratio is what? 1:1, based on this equation of what? Reaction, right? Fine. This equation of reaction is what we are using. So from the mole ratio, of reaction, 1 mole of EDTA reacted with 1 mole of calcium ion, right? Therefore 0.00045 mole of EDTA will react with what amount of what? Calcium ion. So of course, since the mole ratio is 1:1, this implies that our X would be what? 0.00045 mole of calcium what? iron. Remember, the volume of the solution that reacted with the 22.5 cm cube of 0.02 molar EDTA was 10 cm cube, right? Which means that this was the amount of calcium ion present in that 10 cm cube, right? Remember, total volume of the two solution was 250 cm cube, out of which only 10 cm cube was used for the titration. So if we have determined the number of moles of the calcium ion present in the 10 cm cube of the solution, the aliquot, right? Then we also need to know or calculate the number of moles that will be present in the total volume of the solution, which is the 250 cm cube. If 10 cm cube of solution contains 0.00045 mole of calcium ion, 250 cm cube of solution will contain X moles of calcium ion. And if we calculate our X here, so our X here will be 0.00045 mole of calcium ion times 250 cm cube divided by 10 cm cube. So this and this will go, and we'll be left here with 0.01125 mole of calcium ion. So this tells us that this was the amount of calcium ion in moles that was present in the 250 cm cube of the solution. Remember, the 250 cm cube of the solution contained the 1.40 grams of the human tooth. Let's look at the question again. Dry human tooth was dissolved in blah 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 triazonitrifide acid. A drop of that was added, followed by 6 molar. That's for neutralization. Now the solution, remember here we're not given any specific volume, we're just a small quantity of concentrated triazonitrifide, so that the volume here was insignificant. Now the solution was then made up to 250 cm cube. Now this is the main volume of the stock solution. Are we together? This is the main volume of the stock solution that contain the 1.40 grams of the human tooth. So that the number of moles of the calcium ion calculated now in 250 cm cube of the solution is what is also present in this 1.40 grams of human tooth. All right, so from here we're going to calculate the mass of calcium ion present in 250 cm cube of the stock solution. Will be given as number of moles of calcium ion times the molar mass, times the molar mass of calcium ion. Now what's the number of moles of calcium ion in 250 cm cube for that we calculate, which is what we just calculated here? That's 0.01125 mole times what's the molar mass of calcium ion? Molar mass of calcium ion is 40.08 grams per mole. So if we evaluate that, we get 0.4509 grams of calcium. So use that 0.4509 grams of calcium was present in the human tooth. Good. Now let's come back here. Since the question was given to us in 2 decimal places, right? The mass given to us in 2 decimal places, then we should also take a mass here to 2 decimal places. And if we do that, that will give us, that's approximately what, 0.45 grams of what, calcium ion. That was what, present, right? So from here now, next is to calculate the average percentage by mass of the calcium ion, of the calcium present in what, in the human tooth. Average percentage by mass of calcium. When you say calcium ion, it's the same thing as calcium present in the human tooth. And calculated as what? And from the question, what's the mass of the human tooth? 1.40 grams. So from here, you can then say that the percentage by mass of calcium ion present will be 0.45 over 1.40 times 100 over 1. So if we calculate that, we get 32.14%, which is the percentage by mass of the calcium that was present in the 1.4 gram of the human tooth. So if this video was helpful to you, drop a comment and hit the like button. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. Always strive to be a better version of yourself until I see you when I'll see you.